2010 FRQ for both the Calculus AB and BC. This is number 2. So let's read the question carefully and make sure we understand what everything represents. So zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposit entries in a special box between noon and 8. So it started at noon and ended at 8. The number of entries in a box t hours after noon is modeled by the differentiable function. So it's differentiable. So what does E represent? So let's write this down. E is the number of entries in the box. And very important to note, these are hundreds of entries. So each of these represents 100, not just one. So we gotta be careful about that. And let's do this. Part A, use a table to approximate the rate. Not what I wanted. Approximate the rate. Okay, in hundreds of entries per hour, so we don't have to convert this because it's already in hundreds of entries per hour at times t equals 6. So we want to approximate the derivative of E. And hopefully you guys are starting to figure this out. To approximate a derivative, so if we use a mean value theorem, we could technically find the average rate of change between these two. Now, that would guarantee us that the derivative will equal that average rate of change at some time between 5 and 7. But it's not asking us to guarantee that the derivative is going to equal something. We're just going to approximate it. So two different things, but it'll technically end up being the same thing. But I just want to distinguish between the two. They're not actually saying find the derivative. We just want to approximate the derivative. So I've done this many times, but I want to give you a visual of what's going on. So if we were to graph these, we would get 0, 0, 2, 4, 5, 13, 7, 21, and 8, 23. Now, I don't even know if it looks like this, but it doesn't matter. I just want you to get a kind of a visual of what it looks like. So I'm just making something up. And they want us to approximate the derivative at, what's it, 6? So 0, 2, 5. So 6 is right there. And they want, oh, why'd I use blue? I blew it. They want to approximate the slope of the tangent line there. And if you see it, because I've done this so many times, how do we do that? If we could only find, you can't see that, can you? Let's make it a little bigger. Oh, that didn't work like I wanted to. Can I make it bigger here? Nope. That's not working. Let's just do a new, oh my. I think I lost those points. Now that's too fat. Too fat. Can I skinny it up? No. Okay. Too fat. In between. Right there. Try it. That's better. If we could find the slope of that green line, that approximates the slope of the purple line. It's a very common question when you have a data table. So let's do this. The work, excuse me. So we want to approximate e prime at 6. And that's going to be e of 7 minus e of 5 over 7 minus 5, which is 21 minus 13 over 2, which is that 8? 8 over 2, or 4. All right, so that's part A. Pretty easy one. That was worth 1 point. Wow, aren't you excited? You got 1 gigantic point there. All right, let's do part B. Let's erase all this. I don't have to erase it. We're good. Use a trapezoidal sum with 4 subintervals to approximate 1/8 of the integral from 0 to 8. We can do that pretty easily. So we want to approximate this with a trapezoidal. So let me give you a formula that you have to know. We'll call this a base. The area of a trapezoid is kind of like a triangle. Instead of 1/2, I shouldn't call that base, it's going to confuse you, but instead of 1/2 base times height, we'll call this h. Nah, I just messed everything up, but we're fine. I'm going to do this. I'm going to call this B1, B2, and call that h, so it makes more sense to you. It's instead of 1/2 base times height, it's 1/2 the sum of the bases times the height. So common mistake, don't forget that 1/8. That's very important because you'll lose that point. So how many subintervals? 4. So our first subinterval is from here to here. So it's t of 0 and t of 2. So to show my work, this is going to be a pain. 1/2 e of 0 plus e of 2. And then the width between those is 2. Or the height. Or the height that I have. I'm going to have to do that 3 more times. The next one is going to be 2 to 5. So the exact same formula. I'm going to write smaller because I'm going to run out of room. And the distance from 2 to 5 is 3. And then the next pair is going to be 5 to 7. So it's 5 and 7. E of 5, E of 7, and the width between those two would be 2. And the last one is going to be 7 and 8. So that's going to be E of 7 plus E of 8. Oh, I'm running out of room. And the width's 1. Yes. Okay, let's plug in some beautiful numbers here. Oh, this is approximate because we're using an approximation. Okay, e of 0 and e of 2 are 0 and 4. Easy numbers. And then 2 and 5 is going to be 4 and 13. So 4 plus 13, the width's 3. And then 5 and 7 are 13 and 21. And the last pair are 21 and 23. All right, now you do not have to simplify this, but it comes out to be because you're allowed to use your calculator, 10.687 or 10.688. Now, let's reread the question and make sure we answered everything. Use a trapezoidal sum with 4 subintervals to approximate the value. We did that. Now they want correct units and the meaning of this. You need to recognize this as the average. To find the average, you integrate a function and divide it by its width, which is 8. So this is the average of E from 0 to 8. But what is E? So we have to look up. E is the number of entries in the box. So what is the meaning of this? So 1 over 8 from 0 to 8 E of t dt. What does that mean? So this answer means that this answer, let's get the units here. So let's talk about how we get units. Let's use Poiple. Okay, what are the units of that 8? That's the width. That's hours. That's where that's coming from. So it's 1 over hours. Now, E of t, if we look, it's hundreds of entries. So that's hundreds of entries. And D of t is again hours. So those hours cancel. So the units is hundreds of entries. So what does this tell us? This gives us the average number of entries, because E is the number of entries in the box. So the average number of entries in the box from t equals 0 to 8 is 10.688 hundredths of entries. That is the meaning of this integral. So that's part B. That was worth 3 points. Let's move on to part C. I need to erase all this stuff. Let me get a fat. Oh, I can't get a fat eraser. Whoosh. Bam. Oh, man. Sorry, you OCDers. It's probably driving you nuts. There we go. Part C. At 8 o'clock, volunteers begin to process the entries. So 8 o'clock, note that that's the end of the day. No one puts in entries in the box after that. They process entries at the rate in hundreds of entries per hour from 8 o'clock to 12 o'clock. How many entries had not yet been processed by midnight? So we have to figure out how many entries were actually processed and then subtract that from the total number of entries, which we were given here. We know that there were 2,300 entries in the box at 8 o'clock. So the number of entries processed, we'd have to integrate the rate at which entries are processed. So number of processed entries equals the integral from 8 to 12 of t cubed minus, now why am I writing all that? Foolish, foolish, foolish. I just put p of t dt. That's the total number of entries processed. I am going to put that in my calculator right now. So math 9 from 8 to 12. I did not put this in my Y1. I should have, but I did not. So I'm doing it the long way. I got 16. Not approximately, exactly equal to 16. That's a beautiful number. So how many entries had not yet been processed by midnight? So number of unprocessed, number of unprocessed equals E of 8 minus 16, which is 23 minus 16, which is 700 entries. Bam! 2 points for that. That was part C. Now part D. According to the model from part C, at what time were the entries being processed most quickly? Most quickly. So you need to interpret what that means. So what does that mean? So you want to know when the rate is maximum. So we have to go back and turn all this into calculus terms. To be processed most quickly, the rate of processing must be a maximum. So we're trying to maximize the rate of processing. But what is the rate of processing? Well, we already found that. I will use this. The rate of process is P of t. So, in other words, for part D, we want the maximum of P of t. And we know this is limited to that. So, here's a question. Where do maximums and minimums occur? Do not get confused with relative maximums and absolute maximums. Relative maximums are when the derivative changes from positive to negative, but a maximum should occur at endpoints or critical points. So first we need to find critical points. So we need to find when P of t equals 0, and we're going to do that on our calculator. So under Y1, I'm going to put P of t. Again, I should have put this in earlier, but I did not because I didn't see it coming. All right, I have it in now. So what I'm going to do, I'm going to graph this, and my windows, I'm going to make it from 8 to 12 for my x min and x max because they tell us that's when they processed. And then on top of that, I just want to know when this equals 0. So I just have to see the x-axis. I'm going to go from negative 10 to 10 and make sure I can see the graph adequately. That's actually pretty perfect. Oh. Now, I just messed up. Because to find the maximum P of t, I need its critical points, and it's when P prime of t equals 0. So what you'd actually do is graph P prime of t, but what I'm going to do is this. I'm going to find P prime of t here, which is 3t squared minus 30t squared. No, oh, whoa. Brain on drugs. Minus 60t plus 298, a simple derivative. Now the reason this statement here, two things are going on. You have to find the derivative and you have to set it equal to 0, but you're not allowed to do both of those at the same time on the calculator. I don't think. So I'm first going to find the derivative and set it equal to 0. So I'm going to put that function in my calculator and graph that. 3t squared minus 60t plus 298. I want to graph that, not the original. Again, I want to do it from 8 to 12. And it crosses twice. So I'm going to put at A equals and B equals. I'm going to find those. So I do second trace, which gives me the calc. I want the 0. And left bound, what are we going by? Oh, I'm going to put 8 as the left bound. 10 is the right bound. And then approximate it. So it's going to be 9.1835. But I'm going to store that in my calculator. So I go to my home screen. Do I go second mode, which gives me quit. X store alpha A. Now that's stored. And I'm going to do that also with the second intersection point. So second calc 0 again. And I'm going to quickly find that. And that's at 10.816497. And also store that, so X store in B. So I found the critical points, and a reminder again, maximums occur at critical points or endpoints. So at this point, I need to find the value of P at the endpoints and at the critical points. Now you could argue that point B is a relative minimum, so it can't be a maximum, but it's so easy to find these values, I think. What are we doing? Oh yeah, we have P of t in our calculator. It's really easy to find those values and just plugging them in. So I have P of t as y1. So in my calculator, I'm just going to do alpha on the home screen. I'm going to get y1, parenthesis 8, and parenthesis, and that one is 0. Now I'm going to do the same thing. y1, parenthesis a, and that gives me 5.0886621108. And then my y1 at B, and that's 2.1911338. And then at 12, and that gives me 8. So the question's asking for at what time. So really read your question, because this is the maximum rate, but it's not asking for the maximum rate. It's asking time. So it occurs at 12. So the entries were being processed most quickly at t equals 12. Done. That took a while. I hope you had as much of a blast as I have. And I don't know. I'm still trying to figure out that Google Meets. Maybe on Friday we can just have a Meets hangout. And even if we don't do math, maybe we can share jokes or something, have a good time. So I'm trying to figure that out. All right, talk to you guys later.